Given question, a 6-cylinder engine produces 100 kW at 1500 rpm. The specific fuel consumption of the engine is 0.3 kg per kilowatt hour. Each cylinder has separate fuel pump injector pipeline. At the beginning of effective plunger stroke of one fuel pump, the fuel in the pump barrel is 4 cc, fuel inside the injector is 2 cc, fuel in the pipeline is 3 cc. If the average injector pressure is 300 bar and average pressure of charge during the injection is 40 bar, specific fuel gravity is 0.899. Fuel enter the pump barrel at 1 bar. Coefficient of compressibility of the fuel is equal to 79 into 10 raised to minus 6 per bar. Calculate displacement volume per plunger per cycle, power lost in pumping fuel, effective stroke of plunger if the diameter is equal to 7 millimeter. Let us understand given data. This is the 6-cylinder engine with power output is equal to 100 kilowatt. So we have to calculate the power produced per cylinder. So power produced per cylinder notation is capital P and it is equal to 100 by 6. Then speed is given in RPM. So speed, we will use the notation N is equal to 1500 revolution per minute. Specific fuel consumption, that is SFC. So SFC is equal to 0.3 kilogram per kilowatt hour. Injection pressure. So this injection pressure is PINJ is equal to 300 bar. Charge pressure. So this is the pressure in the cylinder. So this is P charge. So we will use the notation P charge is equal to 40 bar. Pump barrel inlet pressure. So this is the barrel pressure. So P barrel is equal to 1 bar. Now we will move to the volume of fuel at the different points. So volume of fuel is given in centimeter cube. So notation, that is the unit is cc. So volume of fuel in the barrel is 4 cc. Volume of fuel in injector is 2 cc. Volume of fuel in pipeline is equal to 3 cc. Now the specific gravity of fuel is also given 0.899. So from this data we can calculate the density of fuel. So this density of fuel is equal to specific gravity multiplied by 10 raised to 3. So from this we can say that density of fuel is equal to 899 kilogram per meter cube. Now coefficient of compressibility of the fuel. So it is given 79 into 10 raised to minus 6 per bar. Now here the bar is the unit of pressure. So all the pressures are mentioned in the bar. So coefficient of compressibility 79 into 10 raised to minus 6. Now which data we have to calculate? So we have to calculate displacement volume per plunger per cycle. Then power lost in pumping fuel. And effective stroke of plunger if diameter is equal to 7 millimeter. So this plunger is in circular shape and its diameter is given 7 millimeter and we have to find out the effective stroke of the plunger. Now we will first find out volume of injected fuel per cylinder. So how to find out this volume of injected fuel? So we have formula to calculate the volume of injected fuel. So that is the specific fuel consumption by 60 multiplied by power output per cylinder divided by RPM by 2 into density of fuel. Now we will balance the notations. So specific fuel consumption, it is given in kilogram per kilowatt hour, but here divided by 60. So this hour is converted into minute. So I will write here kilogram per kilowatt into hour. So in 1 hour there is 60 minutes. So if we in denominator if we multiply here with 60, then it will be converted into minutes. So I will write here minute. Power output per cylinder. So this is the power output per cylinder P, 100 by 6, unit is same, kilowatt. So it is in the numerator. So in numerator I will write here kilowatt. Then in denominator revolution per minute. So here I will write revolution and per minute, that is divided by minute. So it will transfer into numerator. So I will write here as a minute. Then density of fuel, kilogram per meter cube. So this term is in denominator. So here is kilogram per meter cube. So it is in the denominator. So I will transfer this in the numerator. Now we will simplify this kilogram getting cancelled, kilowatt, minute is getting cancelled. So here meter cube per revolution. So this volume is meter cube per cycle. So whatever is the answer, unit is meter cube per cycle. Now we will put the data. So here SFC 0.3 and divided by 60. So I will directly write 0.3 by 60. Power output per cylinder 100 by 6. RPM by 2, that is 1500 divided by 2. I will transfer this in the numerator. And density of fuel. So it is from the specific gravity of fuel, that is 0.899 into 10 raised to 3, that is 899. So answer is 1.2359 into 10 raised to minus 7, and here unit is meter cube per cycle. Now we will move to the formula of coefficient of compressibility. So this is compressibility is because of the pressure difference in between the injection pressure as well as pump barrel inlet pressure. So the pressure is minimum at the inlet of pump barrel, and if we observe the injection pressure is higher. So pressure, as the pressure is getting increased, then there is the difference in pressure and there is the compression of the fuel, and this is known as the compressibility of the fuel. So we have to consider this difference in injection pressure as well as pump barrel inlet pressure. Now what is the formula for coefficient of compressibility? So it is change in volume per unit volume divided by difference in pressure causing compression. So change in volume, that is V1 minus V2 divided by per unit volume, that is the initial volume divided by V1, and divided by difference in pressure causing compression. So P injection is higher than P barrel. So we will take the difference P injection minus P barrel. Now how to calculate this V1? So this V1 is total initial fuel volume. So we know that as there is the compression process, there is the change in volume also. So this initial volume is V1 and final volume is V2. So initial fuel volume, that is equal to, so how to calculate this? So volume of fuel in barrel plus injector plus pipeline. So all these volumes are mentioned in the question. So we will take the addition of volume of fuel in barrel, injector and pipeline. So it is 4 plus 2 plus 3, which is equal to 9 cc, that is 9 centimeter cube. So V1 minus V2. So from this formula we can say that here is K. So K is equal to V1 minus V2 by V1 divided by P injector minus P barrel. So how to find the value of V1 minus V2? So we will transfer all the terms to the left hand side. So it is K multiplied by V1 multiplied by P injector minus P barrel. So here K, value of K we have to take as it is 79 into 10 raised to minus 6. V1 is 9 cc and here is P injection minus P barrel is 300 minus 1. So this bar is getting cancelled because K is having unit per unit bar and this pressure is having unit bar. So only remaining term is Cc, that is centimeter cube. So V1 minus V2 is also in Cc. So answer is 0.212589 Cc. Now we will calculate displacement volume per plunger. So it is the formula V1 minus V2, that is change in volume plus volume of injected fuel. So we have calculated earlier volume of injected fuel in meter cube per cycle, and this V1 minus V2 is in centimeter cube. So V1 minus V2 is 0.212589 centimeter cube plus, now volume of injected fuel 1.2359 into 10 raised to minus 7 meter cube. Now we have to convert it into centimeter cube. So 1 meter is equal to 10 raised to 2 and it is having cube, that is 3 multiplied by 2, that is 6. So we will multiply here 10 raised to 6 and unit is Cc, that is centimeter cube. Now we will simplify this. So if we simplify this, 10 raised to minus 7 into 10 raised to 6, that is minus 7 plus 6 is equal to 10 raised to minus 1. So it is the value 0.12359. Now when we calculate this, 0.336 Cc. So this is the displacement volume per plunger. Now we have to calculate the effective stroke of plunger if diameter is equal to 7 millimeter. So how to calculate the effective stroke? So for that we have to consider displacement volume and it is given in centimeter cube. So 7 millimeter is equal to 0.7 centimeter. So we have to use the value of D is equal to 0.7. So it is the formula pi by 4 D square L, that is equal to 0.336. Now D is equal to 0.7. So we will put the value. And what is the stroke? So effective stroke is nothing but this value of L. So L is the stroke. So L is equal to, so when we calculate this, 0.873 centimeter. Now we will calculate pump work. So it is having formula half into P injection minus P barrel. So we know that this difference in pressure P injection and P barrel causes the compressibility and change in volume is known as V1 minus V2. So when we take the difference P injection minus P barrel, we have to multiply with V1 minus V2. So this is the first term. Now this P, the standard unit is Newton per meter square. So we have to multiply with bar into 10 raised to 5 to convert it into Newton per meter square. And this change in volume is having standard unit meter cube. So this V1 minus V2, which is in Cc, that is centimeter cube, we have to convert it into meter cube. Plus, now we will move to the second term, P injection minus P charge. So the difference in between this injection pressure and charge pressure causes the process of fuel injected. So we have to multiply the volume of injected fuel. So when we take the difference injection pressure and charge pressure. Now this P is also having the standard unit Newton per meter square and the volume of injected fuel we have to take the unit meter cube. Now we will put the value. So half into 300 minus 1 multiplied by 10 raised to 5 because we have to convert this bar into Newton per meter square. Then V1 minus V2. So V1 minus V2 is in centimeter cube, that is given. So we have to convert it into meter cube. So we will multiply with 10 raised to minus 6. Plus, now we will move to the second term, P injection minus P charge. So this 300 minus 40 and multiply with 10 raised to 5 to convert it into Newton per meter square multiplied by volume of injected fuel. So this volume of injected fuel we have calculated in meter cube. So we will keep as it is 1.2359 into 10 raised to minus 7. Now I will underline the first term and second term. So this is the first term and this is the second term. So for the first term answer is 3.17 and for the second term answer is 3.21. So when we add this, then 6.38 joules. So this is the pump work. So when we take this P in Newton per meter square, so I will take here Newton per meter square, then this is in meter cube. Here is also Newton per meter square and this is in meter cube. Then we will get the answer 6.38 joule. Now we will calculate power lost in pumping fuel. So we have to use this term pump work. So pump work is given 6.38 joule. Now we will convert it into kilojoule. So we have to divide by 1000. So this is in kilojoule. Then we have to multiply this RPM. So RPM by 2. So this RPM, revolution per minute, we have to convert into revolution per second. So again we will multiply here with 60. So this term will be in RPS. That is revolution per second. Now we know that joule per second is known as watt. Joule per second is known as watt and kilojoule per second is known as kilowatt. So this power lost we will get the answer in kilowatt because here is kilojoule per second. Here RPS, that is revolution per second. So here this is the formula, power lost in pumping fuel is equal to pump work multiplied by the speed n divided by 2, but speed should be in RPS. So we will multiply here with 60. So here answer is 0.08 kilowatt.